So hi everyone. So today we're going to discuss about star schema and Snowflake schema. Okay. So about star schema, the Snowflake schema. So what are schemas? When we going to use these schemas? Okay. So uh, here we have right when we are receiving data from different sources from Oracle, SQL Server, ER system. So from different sources into S3 bucket. So thereafter, we need to load the data into the Snowflake table from S3 bucket to Snowflake. But so when the project started, like maybe healthcare data mining project and bank project or retail projects. Okay? So when the data we going to receive multiple files. Okay? So multiple files like maybe 200 files, okay? Like that. So these data we need to maintain properly. Properly means how we going to maintain. Like so, which table belongs to what is the table name? What are the fields in the table? So like that we have. So we need to create one table. So from one file we have 10 rows. So we need to load 5 rows only. Five sorry 10 columns. We need to load the 5 columns into the one table and remaining 5 columns into the one more table. So like that. So there will be data architect. Okay, architect. We have developers, admins, DBA, architect, right? So there are different roles. Suppose there is like so data architect. Okay? So we're going to the structure of the tables. How are you going to and data analysts also. These are format. Data architect. What is the tables and what is the fact tables and dimension tables. Okay. Here we have star schema and Snowflake schema. So in star schema, so we have fact table. So fact table, this table having like IDs, okay? Patient ID, okay? So doctor ID, okay? Doctor ID and different, okay? So only ID, numeric data and mobile number, okay? Mobile number. So those details have fact table only. These are primary keys, patient ID. So in fact table, these are primary keys in the dimension tables. So in the dimension tables, these are primary keys. Okay. So in star schema, so we have one fact table and dimension tables. In fact table, it's going to store numeric data, only IDs like the numbers. Okay. So in dimension tables, it's going to store like description data like city name, doctor name, patient name. So these are going to store in the so dimension tables. Okay, dimension tables here. Okay, so here we going with like next Snowflake schema. Snowflake. Here also we have fact tables and dimension tables. Okay, dimension tables. Then we also have the subdimension subdimension tables. Yeah, okay. So in star schema, they will ask in the interview what is the difference between star schema and Snowflake schema. So in star schema we have fact tables and dimension tables, and in Snowflake schema we have fact tables and dimension tables, and also we have sub-dimension tables. Sub-dimension table like that, it's going to store like region, date, like that, those columns. So here, remember fact having numeric data, dimension having description data. Same here also numeric data, description data. So same description data, this data. So how you implemented stars schema in your project? You need to go with Snowflake schema or star schema. So if data is query, like we are writing multiple queries and we are finding sales summary. Okay, in the scenario we're going to use star schema when it's going to be should very quick, like performance wise it should be best. In that scenario we go with Snowflake schema. Okay, should be no need to be performance, just we need the require the output, but here so we need the performance should be best. Snowflake scheme. So in that scenario we going with Snowflake scheme. So here, so it is okay. uh, Top down model. See, star schema is top down model. Okay, and this is bottom up model. Bottom up. So top down model is like so we have data, right? Already it is ready data fact and dimension tables. So from the two down, okay. Uh, Bottom up model is from starting to source to okay, target, like that. Sequence order, so basically. Okay. So this is star schema is denormalization. Okay. Denormalization and Snowflake schema both normalization and denormalization. Okay. So this is denormalization and this is normalization. Okay. So now we'll show the diagrams. Star schema. Okay. So this is a fact table and these are the so dimension table. Dim customer, dim product, dim date, dim store. Here fact sales. Here we have sales ID, customer ID, yeah, date ID. Here we give, okay, it depends on, like suppose this is customer ID primary key, right? In this dim customer ID primary key. This is primary key, product ID, store ID and date. These are primary keys. Okay. So here we using this customer ID. We are using this one. Okay. Again we also have the product ID. Okay. It is not having now, but we also have the product ID, and we also have the store ID. Okay, and we also have the date ID. Like that, we're going to design the fact table. Fact table have only numeric data. So for the sales ID is the primary key for the fact, and the remaining all customer ID, product ID, date ID, store ID. So we don't have, we don't, we're going to have in this C in the fact table. Okay, so this is how to create like a star schema when we are receiving the data. So Snowflake schema. Here we have fact sales, sales ID, customer ID, product ID. So in it, we have these are dimensional tables. So dim customer, dim product, dim date, so dim store. Okay. So these are the dimension tables, and dim region, dim category like sub-dimension tables. Okay. So this table going to connect with everything. Okay, everything. So this is like Snowflake schema and same numeric data. So here we have description data. Okay, say primary key. So all primary key, this customer ID, product ID, and data ID, store ID we have in this fact sales table, and this is the dim region, primary key region, and it going to be have in these tables. Okay, in these tables, and this is also categorized in these tables. Primary key. Okay, so directly we don't need category ID to the fact table, region ID to the okay, to fact table. Okay, so these are connections, but these are connected with fact sales, right? So then it's going to work, and we're going to give the foreign key relationship to the each table. I will show how to create it. Okay, so this is Snowflake scheme. Okay, so here see some definitions. So main, this is very important. Okay, difference between having, okay, here see data model. So star schema is top down model. So okay, let's talk the schema bottom up and the normalization. So star schema denormalization and Snowflake schema both normalization and denormalization. Query complexity here low, but here high. So storage will star schema will take the high and Snowflake schema will take the low. So this is simple and flat data structure, and if you are running any complex queries or relation, we go with Snowflake. So this one. So fact table have only Central table transactional quantitative data. Quantitative data. Dimension tables design supporting tables for description attributes like city name. Attribute means columns. Okay, city name. Okay, or employee name. Okay, doctor name, patient name. So this is denomination. Keep dimension tables wide by adding all necessary attributes. Okay. So what we are adding like names or regions. So foreign keys link to the fact table to the so dimension table using foreign keys. Okay. We need to link the tables fact and dimension. Okay. So we need to when we receive data we need to implement these data. Okay. You can also see key features normalization level. Okay, and generalization again is going to support only few genes. So but in Snowflake schema we are using normalization for multiple genes. So we are like for depends on the what are the type of project. So what are the data we're going to receive in that scheme. So now we go with star schema, Snowflake schema. So performance fast queries, but here performance slow for large genes only. Okay, storage will take more space, it will take only less space. Okay, if say less space. Okay, so this is really also. Then here we have we seen that okay, first we going to implement star schema, then we go with the Snowflake. So here I'm using raw database use. So database name statement execute actually. Then I'm creating one new schema. Create schema. Okay, schema name is forward. Okay, this is schema name. Okay. So directly you can raw database. So by default, when I create the raw database, okay, here I have okay, this is star schema or public schema. So these are schemas inside this raw database. So then we're going to paste that content here. So so to go with this database. So I'm creating online retail database. Then online retail star schema I'm creating. Okay. So use schema name online retail data warehouse stars. Okay. So first I'm creating dimension tables. Okay. So dim customer I'm creating inside we have data. So customer ID int and primary key. Okay. So customer name string and gender string and region string. So this is the okay. See how we going to connect you will connect with these tables with the fact tables. So agency dim product ID is a primary key. Okay, then we have product name.
Bro, hello.
Yeah,
Bro, once we created the dimensional models, I'm talking about like a star schema. If we select star all from table name, it will data will be there, only ones and twos will be there after creating of dimensional tables.
data will be, we need to insert the data, right?
Yes. After creation, total table was created, dimensional tables was created. So if you select the select a star from table name, so the data will be ones and twos, or like a normal data it will be there,
So what
like a
data we
strings
going?
and
So when we create the table, you know how to create table, right? Like that only I'm creating.
yeah, yeah.
Yeah, if the data will be there in the table, we're going to see the data. If there is no data, we can't see. So after creating the table, we need to insert the data. If you insert the data, then we can see the data. So without inserting, we can't see the data when you select the table. So here, in product table, product ID, saint primary. Okay, product name, string. So category string and brand string. Okay, so this is drill product. Okay, then create a dim date. So here we have date ID. It is a primary key and day int, month string, year int. Okay, quarter. Okay. So then we have create a record table dim store. So store ID here we have it is a primary key. Then inside store name, city, state we have these. So create a request table fact. This is the fact sales. Okay. So sales ID and int primary key is related to the fact table. Okay. Here we have customer ID from which table we are taking. So from the dim customer we are taking. Okay. So then here we have the product ID from the product table. Dim product. Okay. So see. And here see we have date ID, store ID. So date ID from this table, div date and store ID from the div store. Okay, like that we need to. So for every table from the every primary key, we need to mention in the this fact table. Then only we will get a proper output. When we are finding. Okay. So these are stories. So and these are other okay, quantity. So we have in the fact sales and total amount. So these are the fact tables. It is also parametric. Here we are not giving any foreign key relationship in these tables. Just we are giving only constraints, primary key constraint. We are not applying any foreign keys here. Okay. So then create back table backspace. Backspace created. So now insert some data. Okay. So dim customer and so dim product, dim date. Okay. So and dim store. Again, okay, insert the in fact table also I'm inserting separate. Okay. Then dim customer we have let's see customer ID, customer name, gender, region, and then uh, so dim date. So check date. In dim date we have so date ID, day, month, year, and quarter. Again we have dim store. Let's check the dim store. So dim store we have so store ID. From which store we are getting store name and which city and state. Okay. So that's so dim store. Okay. So next, template to store. Okay. Then this factor we want select fact six. In this we have sales ID, customer product ID, date ID. So the quantity and the total amount. So this we have instead. So from this data, we're going to find, okay, some of from this account, okay, like total amount, okay, we're going to find, so in which month and which customer and he bought which product and what is from the which store and what is the quantity and what is the total amount for that. Okay, so a customer is every month from the any store he goes, so he buy any one product there. How many products he bought? Okay, what product he bought and what is the quantity, and final what are the amount for that. So that is we are finding. So for that we need to write a query. We need to join all these tables, fact and dimension tables. We need to find write a query. Then we need to find. Okay, here see select D dot month. So these are alias name B C P S F F alias name. So D dot month, C dot customer name, then P dot product ID, and then again we have store name. Okay, let's start store name, fifth dot quantity, and the total amount. Okay, so these are the month. Okay, month. Okay, here we have month, right? In this hotel store, this team date. So what here we have customer name, okay, product name, store name, quantity, total. So from fact sales, okay, we are mentioned these are from the fact sales, okay, and the ones from the which and different date table. Then from fact sales, so Jane join the customer alias LC on, so f dot customer ID equal to c dot customer ID. F is fact table, c means dim customer. Okay, again we are equal. So we are joining and join, okay, dim customer and f alias name. So f dot data ID and this one chain dim product on f dot product ID equal to p dot product. Again chain dim date, okay, on f dot data ID equal to data. We have common, right? Okay. So data ID we also having the factor. Here we also have. Okay. So again dim store, okay, store ID, okay, dim store fact table store ID and store ID. And we haven't mentioned any sales ID. We haven't mentioned anywhere sales ID. Okay, we haven't mentioned anywhere sales ID. Okay. So for each table we have customer ID, team customer, product ID, team product, and date ID, team dates, and store ID, team store. So from each table we have primary key. We are joining with the fact table because of, so we have common column from the import fact and some tables with different keys, like here we have customer ID, product ID, data ID, and store ID. Then we run. So what you going to find, a customer he bought a different products from the a store, another store name, and what is quantity and what is total amount he spent on that product, like that we going to see. Here, this customer, Ella Johnson, in month of August, okay, she got a product named laptop from store A. So she bought two laptops quantity, and for that she paid $1,500. Okay, so this is how we need to find. Okay, from different tables, we need to go first with theory. Okay, so the simple table having month, customer name, product name, store name, quantity, total name. That's fine. But what it's showing the data. Okay, so again, Bob Smith, you go in August. So you got a smartphone from the store name store B and quantity you got only one. So what is the total amount for $200? Like this. Okay, so we need to understand. Okay, so this is the how what he happened. Okay, this data going to share by the BI tools. So when we have created everything, okay. So we're going to write, we're going to create different tables. Okay, we're going to write different queries from the fact and dimension tables. Okay, and we're going to give these. Okay, we share with the BI tools. Okay, so this is like star schema. Then we go with the Snowflake schema. Okay. So Snowflake schema, how does it having fact table, dimension, and sub-dimension tables. So next check the Snowflake schema. Okay. So I'm selecting new worksheet as a host. It on Snowflake schema. Okay, database online retail Snowflake. Okay, create a schema on retail Snowflake schema. The new schema on retail Snowflake schema. Then here goes create a replace dim region. Okay, so dim region. So region ID in primary key. Okay, so these are subdimension tables. Remember. So first I'm going with the subdimension tables. Okay, dim region ID, the primary key. Okay, see and dim category ID primary key. And then so here we are creating the dimension tables. When we are creating the dimension tables, so see what are the columns we have: customer ID, customer name, gender, region ID. So customer ID is primary key in this customer dim customer, and here we have customer name and gender. Okay, this primary and a region ID from the this region ID into primary key. We have that primary key we are using in the dim customer table. So region ID, how to mention foreign key relationship. Okay, uh, the region ID. So after we need to mention like data type. Then after so what references? What is the references for this region ID? Someone given references. Okay, who is given? So references team region table. So inside that column name region ID. Okay. So region ID data type who given references for the region ID into the then customer table dim region table is given. So you need to mention the dim region and then we have region ID column. So like that we need to understand the concept. Then you can when you're creating applying these references or foreign key, then you can understand this. Okay. Region ID data type with the who references given dim region. So region ID from this table. This is table name dim region. This is the column in the region ID table. Okay. So this is the dim customer get create. Okay. So see and we have not created a tables. So first create these tables. Then dim customer. So create get dim customer created. Then again dim product. So in dim product what we have product ID, product name, category ID, brand. So product ID is a primary key and product name, okay. Again category ID. So category ID we are taking from the different table. So from the which table we are taking category ID? So again dim category. So here we have dim category table, right? So category ID. Okay, we are taking from that here. Okay, see. Okay, so dim category. Product ID, primary key, product name and category ID. So data type, okay, who give differences. So dim category table given. Okay, in the dim category table we have the category ID. And again brand. So like that create a dim product table. Then see. Okay, this is the dim product table. Okay. So then I can go with the dim date. So in dim date, we not differing. We don't have any reference. So it's again date ID, day, month, year, quarter. Okay. So about type, primary key is a data ID. So we create a replace fact. So team store. Okay. Here we have store ID, primary key, store name, city, and state. Okay. And again create the fact table. Okay. So this is dim store. So usually store ID, primary key, and store name, city, state. So in fact table, how we are creating? So fact table, we have sales ID. So it is sales ID. It is a primary key in this fact table. So again, see, customer ID int refers in star schema. What we have done star schema, we have not written anywhere references. But in Snowflake, we need to mention. Okay, so customer ID, someone giving the references from the table. Okay, take customer. See, here we have customer ID, right? So this we are taking customer ID into the fact table. See, so there is only 2 minutes. Jane again, everyone. Region with the same link. I will explain.